Hey guys, this is Brian Barbosa. I'm a computer science student at the Federal University of Juiz de Fora in Brazil, and also I am a researcher for the Center for Research and Education on Aging, CREA, from the University of California, Berkeley. Today I'm going to show you how to connect your Vocore 2 to max6675 module for monitoring the temperature using a thermocouple. Okay, we are going to do this through a micro library that we developed on CREA that uses Python, and it's based on the Arduino commands for connecting and controlling the thermocouple and the model. Okay, today I'm using Ubuntu. I'm frequently changing, as if you watch the other videos, you will see that I was using Windows. On the first video I was using Ubuntu, then I started using Windows. Now I'm back on Ubuntu again, but the process of connecting and controlling the Vocore is almost the same. It's not very different, okay? So let's go. The first thing you have to do is connect to the Vocore network. I said that on the other videos. For controlling the internal system and sending commands and things like that, you have to be connected to Vocore. Right now I'm going to connect to Vocore using a wireless network, but you can also connect using a wired-based connection, okay? There is no problem with that. Let's connect here. I'm going to select the network. Here's the Vocore, okay? And I'm going to connect. Okay, now I'm connected to the Vocore. I can now open the terminal and connect using this command, ss8, the IP of the Vocore, the IP address, which is 192.168.61.1 minus L and space root. Okay, you can see on the screen. Okay, I'm going to press enter now, and it's going to ask me about the password. Normally, by pattern, the Vocore comes with the password as Vocore. Okay, so you can type Vocore if you didn't change it. Okay, as you can see, it's the initial screen of the Vocore. I'm going to type ls now, just to see what files can we find here. And we have here the blink LED of the other tutorial. We have here the library for receiving signals from the model of the thermocouple. Here I was doing a test for what we are going to do now on this tutorial. And here we have the GPIO library for controlling the pins. Okay, I'm going to delete the file of the temperature.py, okay, using rm temperature.py, and if I type ls again, you can see that it's not here anymore. Okay, it was here, but it isn't anymore. Okay, now I'm going to create my own with you. Let me type here vi and the name of the file I want to create. Okay, I'm going to put here temperature.py, and now it opens empty file, as you can see, and we will not be able to type anything. But if we do not press the key I before we start, okay? I'm going to press I now, and now I'm able to write anything I want. Okay, the first thing I'm going to do is import the model, import the library to connect to the model. Okay, from max6675 import everything. Okay, and I'm going to import to the Vocore GPIO library. Okay, Vocore GPIO import everything. Okay, now I'm going to define the pins that of the Vocore that are connected to the thermocouple model. Okay, the first pin that we are going to define is the SCLK. Okay, we are connecting it to the pin 39, and in some models it can be also called CLK. Okay, I'm going to comment here. It means serial clock input. Okay, now I'm going to define the second one, and CS is connected to the pin 40. Okay, it CS means chip select. Okay, and the third is MISO. Okay, or MISO. I don't know how would you say that on your language. You can comment it right below on the comments. Okay, it is on the pin, let me see, 41. In some models you can find it as SO. Okay, it means serial data output. Okay, now I'm going to create an object of the class of the thermocouple model. Okay, I'm going to call this object T, and T equals to max6675 SCLK CS and MISO or MISO. Okay, now I created this object. I'm going to create a loop so it keeps repeating, monitoring the temperature. Okay, it calls the temperature monitor, and then prints it, then wait for a few seconds and calls the function for monitoring the temperature again. Okay, it's going to repeat eternally, so or while we keep running this program. Okay, so I'm going to put here, type a while 1, and I'm going to call for the temperature in Celsius first, the second one is going to be the temperature in Fahrenheit. Okay, Fahrenheit, and the third is going to be the temperature in Kelvin. Okay, I'm writing the program here on the Vocore's terminal, but you can also write on your computer and send to the Vocore, as I did in another videos that you can see on this channel. Okay, there's no problem with that. Program will work in the same way. Okay, I'm just doing that because I think it's more easy to do when you are working with small program. Okay, now I'm going to print. Okay. The last thing I'm going to do is to type a command to a delay. So I want it to have a break of 3 seconds. Okay, so I'm going to type delay, and as a parameter I'm going to pass 3000. Just remember that the delay function works with milliseconds. Okay, if we want 3 seconds of delay, we have to type 3000. Okay, and now I'm going to press ask WQ and save the program. If I type ls here, we can see that we have the program now. Okay, I had a problem here on my computer, but back again. I just saved the program we created. Okay, if we type ls here, you can see that the program is here. We just created it. If you hear any dogs barking on this video, is my neighbor's dogs, and there's nothing I can do against that. I'm sorry for that. Now I'm going to run the program we just created, and by typing Python temperature.py. Okay, let's see. Okay, the first reading sometimes comes with not a number, but you can see now that it's working. It's reading the temperature in Celsius, Fahrenheit and Kelvin. You can limitate the number of decimals with a simple and normal Python command. Okay, it works just like on the normal Python programming command. Okay, it's Python, people. It's not like it's a different kind of Python for this program. Okay, right now it's 30 degrees Celsius on the city that I am. It's very hot here now. I think the temperature is increasing. No, it's about 31 degrees. Hey guys, I thought it was important to show you how the Vocore connected to the thermocouple interacts with the environment. So I'm connected to the Vocore now with my cell phone. Here, I'm going to connect to the Vocore network. Okay, now I'm connected, and I'm going to do the SS8 connection that I showed you before. Okay, now I'm going to run the program we made a few minutes ago. Okay, Python temperature.py, as you can see here. Okay, enter, and it's going to take the readings of the temperature, as you can see here. And now if I take the tip of the thermocouple and hold, you're going to see on the screen that the temperature is going to start to increase because my body is warmer than the environment. Okay, so that's how the thermocouple works. Okay, I hope you enjoyed the video, and that's it. That's how we can use this model. If you liked the video, please subscribe on the channel, give a like. If you have any things to suggest, you can comment right below. If you want to do some requests, you can write below too. And if you have anything that you think you could modify on this micro library that could make it better, you can do a pull request on our repository on GitHub that is on the description of this video. And I forgot to say, but it's also that the library is free to use, to modify, to distribute, and to do anything you want with it. Okay, thank you and bye bye.